Welcome to another example of finding the partial fraction decomposition of a given rational expression. Notice in this example, the denominator is already factored where we have one linear factor and one quadratic factor. But before we start, it's also important to notice that the degree of the numerator is less than the degree of the denominator. Notice if we multiplied out the denominator, we'd have degree 3, the numerator is degree 2. So we can go ahead and set up our partial fractions. We'll start with the original rational expression. Notice how this quadratic here does not factor again because there are no factors of positive 1 that add to negative 1. So because we have two factors in our denominator, we'll have two fractions in our decomposition, where the first denominator will be the linear factor x minus 2, and the second denominator will be the quadratic factor x squared minus x plus 1. For the linear factors, the numerator is always going to be a constant, so we'll use the variable a since we don't know that constant yet. And then for quadratic factors, the numerator could be a linear factor, meaning it could be in the form of bx plus c. Notice how we started this with b because we used a here. And now for the next step, we're going to clear the fractions from this equation and then solve for a, b, and c. So to clear the fractions, we're going to multiply both sides of the equation by the LCD, which would be the quantity x minus 2 times the quantity x squared minus x plus 1. Notice on the left side, this simplifies nicely, x minus 2 over x minus 2, and the quadratic factor over the quadratic factor. So we're left with 5x squared minus 8x plus 5. And on the right side, this first product, the linear factor simplifies out. So we have a times the quadratic factor x squared minus x plus 1. And then for the second product, the quadratic factor simplifies out, leaving us with the quantity bx plus c times the quantity x minus 2. And now to find the values of a, b, and c, we can use a method called equating the coefficients, which is where we multiply the right side out, then group the like terms in terms of x together, where we'd have x squared terms, x terms, and constants. We would factor those, and then set the coefficients of those terms equal to the coefficients of the like terms on the left. But in this video, we're going to use a shortcut method, which is where we select specific values of x, more specifically the values of x that would simplify out several terms in order to find the values of a, b, and c. For example, notice if we select x equals 2, the factor of x minus 2 would be equal to 0. So let's start there. If x equals 2, we'll substitute 2 for x. So here we'd have 2 squared, that's 4 times 5, that's 20. Minus 8 times 2, or minus 16, that's 4, plus 5, that's 9. And now on the right side, again, if x is 2, we'd have 2 squared or 4, minus 2, that's 2, plus 1, that'd be 3. So a times 3 would be 3a. And then over here, if x equals 2, this would be 0. 0 times anything is still 0. So notice that we have the equation 9 equals 3a. Divide both sides by 3. So now we know a must equal 3. For the next value of x, let's go and select x equals 0, because that would at least eliminate the bx term. So if x equals 0, we would have 0 minus 0 plus 5, that's 5, equals, again, if x is 0, this would just be 0 minus 0 plus 1, a times 1 is a. And then for this last product, if x is 0, we would just have c times negative 2, or minus 2c. This equation does have two variables. We already know a must equal 3, so now we'll substitute 3 for a. That would give us 5 equals 3 minus 2c. Subtract 3 on both sides, that would give us 2 equals negative 2c. Divide by negative 2, c equals negative 1. Now we still need the value of b. So looking at our equation on the right, I can't see an obvious substitution for x. So let's go ahead and use x equals 1. But remember, we also know that a equals 3 and c equals negative 1. So if x equals 1, we'd have 5 minus 8, that's negative 3 plus 5. it's going to be positive 2 equals, and on the right side, if x equals 1, this would be 1 minus 1 plus 1, so that's just 1. Remember, a is equal to 3, so we'd have 3 times 1 plus, here we have bx plus c. We don't know b, but we know x is 1, so we just have b plus c, but c is negative 1, so we have b minus 1 times, again, if x is 1, this would just be 1 minus 2, or negative 1. So notice how this does give us an equation with one variable, which we can solve for b. So we have 2 equals 3, distribute negative 1, we'll have minus b plus 1. Combining like terms, we have 2 equals 3 plus 1 is 4. Subtract 4 on both sides. So we have negative b equals negative 2. Divide both sides by negative 1. And we have b equals positive 2. Now that we know the values of a, b, and c, we'll perform the substitution into our two fractions here for our partial fraction decomposition. And we'll go ahead and do this on the next slide. So now that we know the values of a, b, and c, the original rational expression is equal to a divided by the quantity x minus 2, or 3 divided by the quantity x minus 2, plus bx plus c divided by x squared minus x plus 1, where b is equal to 2 and c is equal to negative 1, which would give us 2x minus 1. This would be the partial fraction decomposition of our rational expression. I hope you found this helpful.